Guess we'll just move on.
Okay. So,
Which one are we doing?
19.
Oh, okay, I got it.
This is 6, 7, number 19. Okay. We have f of x equals x cubed minus 4x squared plus 16x minus 64. Okay. And it wants to know if this is a solution. Okay. So here's what you do.
Oh. That makes a lot more sense than what I did. I thought you could just do that.
Yes. Because there are the remainder theorems. There's the remainder theorem, and there's also the factor theorem. So, the factor theorem states that if you plug this in, and your answer is 0, it's a root. The remainder theorem says if you use synthetic division and your remainder is 0, it's a root. So you can do either one.
Okay.
So then this is going to become 64i cubed minus 64i squared plus 64i minus 64.
So you could take out a 64.
Yes.
Oh, a negative 64.
So I cubed, remember, I cubed equals negative I. So this simplifies to negative 64i. I squared equals negative 1, so this becomes plus 64. Then we have plus 64i minus 64. Negative 64i and 64i are additive inverses, so they add 0, and so are 64, negative 64. So, yes, it's root. What does that tell me about negative 4i?
That would be, oh wait, that would be. Ouch.
Anybody?
Huh?
What do I know about negative 4i if 4i is a root?
Then negative 4i is also a root?
Right, because they're conjugates. They have to come in those pairs.
That makes
Okay, do you want me to do 20?
sense. Yes.
Okay.
Wait, Oh wait, never mind. Sorry.
Okay. 6, 7, number 20. F of x equals x cubed minus 3x. Oh, you're going to do thank you.
Plus x minus 3.
I'm testing x equals negative I. Okay, so f of negative I equals negative I cubed minus 3 negative I squared minus I minus 3. So, negative I cubed is negative I cubed. Negative I squared is I squared, so minus 3I squared minus I minus 3. Simplifies to I cubed equals negative I, so this becomes a positive I because it's a negative negative I squared equals negative 1, so this becomes plus 3 minus I minus 3. Additive inverses equals 0. So yes, it's a root. Additional questions?
On a lot of them, I got like the first two out of the 4.
Okay.
So how do you find the other one?
Well, it depends on what the problem is. Do you want to give me an example and we'll do it together?
Yeah, like number 26.
Okay.
Wait, was that a yes for that one?
Yes, because it equals 0.
Okay.
Okay, number 26 says f of x equals x to the 4th minus 5x squared minus 36.
Okay.
I got -3 and 3.
And the other ones are going to be plus or minus 2i. And I'll show you why.
Yes. Oh yeah, that's right. I remember. But yeah, like how do you find that?
This is a quadratic. Even though it says it's a quartic, if I substitute like u equals x squared, this becomes u squared minus 5u minus 36. Which factors? Factoring is always the easiest. If you can factor, do it. -9 and 4. So this becomes u minus 9 times u plus 4. Substituting x squared back in. This is a difference of squares because it's x squared minus 3 squared. So that's going to become x minus 3 times x plus 3. X squared plus 4 is not factorable in the real number system. So now we're going to set all of these equal to 0. And we get that x equals positive 3 from here, negative 3 from here,
Yeah.
and x squared plus 4 equals 0. So x squared equals negative 4. So square rooting both sides. X equals plus or minus 2i.
I thought in the answer Q is plus or minus just I.
Shouldn't be.
Maybe I was looking at the wrong one.
I'm really
There
confused.
should be an answer key for the evens anyway.
Oh yeah.
No.
You're right. It was for a different one.
For
I'm confused.
49 through
Okay.
the end, I'm just like, I've done it so many times now, and every time I've done them, they're wrong.
Okay.
I'm a little confused.
Let's go.
What I'm supposed to do.
Okay. So this is 49?
Mm-hmm.
Wait, what did you get for that one?
You switched up.
Do you have an answer for 41?
It's pretty weird.
So I got -0.47, but there's probably supposed to be
I got 2,
one.
1.5, and -3. I think you got it right.
I don't know.
I know I got it wrong.
I just graphed it and looked at it.
Oh, this one's super easy. I don't need to do this on a board. And when I mean super easy, I don't mean like it's so easy. I can't believe you struggled with it. I mean, I don't have to do any work by hand. So,
Yay.
Wow.
Because it's all calculated.
and that's only because it says to do the whole thing in the calculator.
So
Please don't be dead.
Oh, I'm on 6.6. I'm such an idiot. What am I even doing?
Oh, you want me to go to 6.6?
Oh no, I was looking at 6.6.
you were like, where's the problem?
I'm so dumb.
No.
47.
Wow.
Oh wait, we might have been both right.
Real
because
smooth.
I think. Wait,
I wasn't even doing the right problems.
no. Oh no.
Okay.
Wait, 6.
That's rough. That's really
Two
rough.
questions?
I can't find the other 2.
What did I do?
So they might be at home?
I did those.
No, the answer.
Ugh.
Oh.
Yeah, I can never find like the other answers either.
How did you know what to test?
I just started testing.
Remember the rational root theorem?
You tried.
Okay.
I get 47, right? Okay. Did this. Okay. So everything's gonna be okay. It's okay.
What?
Like listing all of them before. But I get confused on the fraction ones, like how they.
A lot of them, I think most of them
Okay.
you didn't have to do fractions.
When? Okay, the fraction ones are all the factors of plus or minus 2, or negative 2, which is plus or minus 1 and plus or minus 2, over all of the factors of 3, which is plus or minus 1 and plus or minus 3. So there's 2 over 3, and then 2 over 1, and then there's 1 over 3 and 1 over 1. So your list would be plus or minus 1, plus or minus 2, plus or minus 1/3, and plus or minus 2/3.
Sorry, can you repeat it?
That's okay. You might want to write down the plus or minus 1 and plus or minus 1, plus or minus 2, and then like separately plus or minus 1, plus or minus 3. So you can see where I'm getting these. These are all the factors of P. These are all the factors of Q. So you're just going to make all the possible combinations of P over Q. So 1 over 1, 1 over 3, 2 over 1, 2 over 3. Okay, that's it. So don't forget that each one of them is plus or minus.
Right.
There you go.
Those are.
So what I would recommend
Wait,
you do
this is just
1, and
Right.
this is just 2.
okay, so I know it's not 1.
Well, it's negative 1. Remember, each one is plus or minus, so it could be either. So there are actually 8 possible roots. Okay. So you have this. You know that that is because you tested it. Divide out negative 2 from this and see what you have left, and then see if that factors.
For this one, for number 30, okay, so I do this. I did synthetic division, I got x minus 1 equals this, and I couldn't simplify this anymore. Can this be simplified anymore?
No, you would have to use the quadratic formula if you're being asked for the
So,
zeros.
what would it be if I did that?
It won't factor.
It won't factor, so what am I supposed to do?
The quadratic formula, because it's a
What is
quadratic.
How do I do that again?
Negative b plus or minus the square root of b squared minus 4ac over 2a.
Okay, so I got that one got to 0.
Uh-huh.
So what is this? Because I already I did this one. So does that represent 2 over 1?
So now you're left with, okay, so it was a quartic. You divided out an x plus 1.
Right.
And now you have a cubic.
Mhm.
You divided out an x plus 2, and now you have a quadratic.
Okay.
So that becomes 3 squared minus, does that say negative 2 or plus 2?
It's plus 2.
Plus 2x minus 1. So write that out somewhere. Write down your new polynomial you're left with.
Can you repeat it? Sorry.
So you're going to be left with a square, right? Because you've already factored out 2 roots from a fourth. So 3x squared, right here. And then what's this one mean?
Plus 2x
Mm-hmm.
minus 1.
Right. So see if that factors. Okay. Which one next?
49.
Oh, 49 and 6.7? The
On-
graphing one?
yeah.
Okay. So,
Just put it into Desmos. Okay, so 55 and 6.7.
55.
I don't know
Okay.
why, but I
For
don't like
1980 through 1996, the total exports in billions of the United States can be modeled by E. This is, 55.
Which one? Oh, 55.
E equals negative 0.13 t cubed plus 5.033 t squared minus 23.2 t plus 233. those of you thinking about going into business, this is a much more realistic problem for a business application. Okay, so where T is the number of years since 1980, in what year were the total exports about 312.76 billion? Okay, so that's E, total exports. So 312.76 equals negative 0.13 T cubed plus 5.033 T squared minus 23.2 T plus 233. Get everything to one side. You get 0 equals negative 0.13 T cubed plus 5.033 T squared minus 23.2 T, and then minus, I don't want to do that in my head. $79.76. And then you factor. Just kidding. That'd be horrible.
That'd be really bad.
Did you do the P over Q? So you're going to have all the factors of 79.76. I'm just kidding. That's also, like, ridiculous.
Put it in the
Okay.
graph.
You just
Put it in the graph.
Okay.
Calculator. So you
That'd
have
be terrible.
negative 0.13. So no T, it's x cubed, plus 5.033 x squared minus 23.2 x 79.76. Last term is always your y-intercept. So when you're thinking about like what kind of viewing window you want to make sure you can see the whole thing. So let's see.
So negative 42.57, negative 2.33, 6.184. That's what I got for the zeros. Oh, games. Okay.
It's okay. I think I got it. I'm pretty sure I got it. And if not, I don't know.
You got 3 of them right.
Can't spread them too.
Is that what you want to stick with, or you want to try to get all 4?
Just do the last one. Why not?
I tried it.
It's not really that ethical as a teacher if I give you this quiz that none of you do well on and then allow you to like have this
Community.
and then I can't just do it for you. That's really
Yeah.
So I'll do my best to help you, but I can't just do it.
I have a question.
Yeah.
So are we doing 6.9 as well today? Or are we doing it Wednesday?
Wednesday.
Okay. Since we have one.
So from here,
Or we
after
wanna go do
graphing it, what would
6.8?
you do with like these numbers? So a little
Because there's the 2 of them, I would actually go back into my function, my y equals, and I would put back in plus 233 because I'm only looking for one answer.
Mhm.
So then I'm going to go into table and see where is my y, 312.76. So table set, just start with 312.76. Do the thing. Go into my table. y to be that. Okay. So hang on. So using my table, I can see it's somewhere in between where x is 8 and x is 9.
Okay.
Does that make sense?
Mhm.
Which means that it has to be
1988 and 1989.
Which is fine because it asks you for what year. So
I read.
I mean, it's 8 and 364 out of 365 all the way up until January 1st. Does this make sense?
Yeah.
1989. So
Okay.
anywhere in between 8 and 9 years, not including 9 exactly, will still be 1988.
Okay, that makes sense.
Okay. Pretty sure this time? I want to say you're closer, but one of them is still wrong.
I'll just leave it.
Are you sure? Where did you factor it? I don't see any factoring.
I thought I got them all right. They all got out to 0.
Did you not factor? But this right here, where are your solutions for this?
I forgot.
So you know that x plus 1 times x plus 2 times this gives you your original. So all you need to do is factor this. That's all that's left. So see if you can factor it.
So I got this one.
The old-fashioned way that we've been doing all year. Okay.
How many points off would it be if you didn't do it?
How what?
Eat my egg. Does anybody care if I eat an egg?
Go for it.
Excellent.
Oh, it's funny.
It's a boiled egg.
Just get I have 4 questions,
Okay.
but is it worth it to go through them, or
I don't know.
should
I
we
don't know
just keep going?
how confused you are.
Because I got 55, so that was exciting. But I didn't get the other 2 the story problems. And then I have 2 other ones that are just like, I got 2 of the answers, but I don't know how to get the other 2.
This is a good egg.
It looks good.
My mom makes the best hard-boiled eggs. It's
I don't know.
I don't know what you do, but you make
This
them
one's really good.
Where did you get it? Or did you
I made
make
it.
Nice.
Who knows what those moms should have an egg off.
Egg off.
Okay, what's your question?
Well, let's do 57 since I think everyone needs help with that. So, we'll be a group
Effort.
yes. So doing homework here. So,
In theory, could you just like not come to class at all and just watch the lectures? Like you could do that, and it'd be like an online class. I know. But, like, technically could.
participation isn't.
For 1987 through 1996, the sales of gym shoes and sneakers can be modeled by that, where T is the number of years since 1987. Were there any years in which sales were about 2 billion? I'm not even going to do this on the board. I'm going to graph it.
Cool. Is my setup right? I guess that's what I should ask then. So I feel like it's not.
Did you do any math before you graphed it?
I subtracted the last number of the equation. I did that minus 2 billion.
I'm not even going to do that because seeing as how this is a polynomial with a degree more than 1, there are 2 possible x-intercepts at the very minimum.
Yeah.
So, I don't want to have to see if it's one or the other. I'm just going to plug in the original function.
Okay.
So y equals.
Y equals, ooh, this is ugly.
Okay.
Negative 982.
Negative 0.98.
Whoops.
x to the 5th plus 24.6 x to the 4th
24.
minus 211 x
24.6
plus 661 x squared minus 318 x plus 1520. Okay. So, if it says the sales S in millions, but I want it to be 2 billion, how many millions is 2 billion?
Oh, what? Sorry.
How many
Million?
Oh, no,
Two
I just
billion?
wait, go back. Wait,
Like-
this is...
That's like hard to like say. It's like
So, you start off with 1 million, right?
yeah, you like
Or
100
2
million,
million.
200 million, 300 million, and 999 million, and it's billion.
Okay, so how many times do we need to multiply by 10?
A lot of
So if you had
times.
1 million, how many times
Oh,
do you need to
that's
multiply by 10 to get to 1 billion?
Million has
How many spaces removed is it?
5 zeros and billion has 6 zeros.
Billion has
No, billion has a lot more.
Billion
7?
has-
9.
9.
There are
Oh, I think that's why I
1,000
have trouble.
million
It's because I forgot how much.
in
billion
every
is.
1 billion. Because if you think about it, you can very easily have 999 million. That doesn't sound weird till you get up to 1,000 million. You're like, what? That's not right. So then you would do 1 billion. So we're looking for where it's 2,000. Does that make sense?
Okay.
Why is
Not really.
2,000?
Okay. Yeah, 2,000. Okay, I
Oh,
got the
one
graph.
step. Okay. So,
I'm almost, there we go, 2,000. There's 3 lines.
table. So this is just saying, were there any years? So this is just a yes or no question, and then you explain.
What's the question again? 57. Were there any years in which the sales were about 2 billion? Yes.
Yes.
3?
I don't know.
Yeah, because if you got 3
There's
results
three
for it,
lines.
then it would be 3.
If there are 3 times it passes through that point, then yes, there are 3 years.
Okay. I don't quite understand. Okay.
Well, it's important that you understand.
I don't get the 2000 part. Why are we looking at 2000?
Because it's asking us, were there any years in which the sales were about 2 billion? So 2 billion is sales, so that represents the Y, right?
Uh-huh.
But our Y's aren't counted in units of 1. They're counted in units of 1 million.
Oh, I see.
Because
And
it tells
we know
us
that
the
because
sales in millions.
Got it.
So we're looking for
Okay.
where the Y value represents 2 billion, but we had to
Yeah.
figure out what that was
Because
going
why
to
does
be in
it
our
equal 1
graph.
might equals like
Right.
every 10 is 1,000 or whatever. Like
Okay.
things. Okay, got it. Okay, so yes. Yes.
I say we just skip out on 59 and move on to the new lesson, because
Is it very hard, or is it just building?
yeah.
It's like already 11:25.
I know.
Yeah. Well, it's pretty easy, actually.
Okay.
It's like 1 page.
Yay. I'm just so hungry, I can't even think.
Ditto. Let's knock this thing out and then
Okay.
leave.
I guess I can just skip the rest of this.
Okay. This is going to be so easy today.
I need a good break.
So on page 373, there is a beautiful table where it summarizes everything that we've been doing in this chapter.
Oh, yay. That's exciting.
Thank you. So it says, if it's a 0, that means that k is a 0 of the polynomial function. And as a factor, x minus k is a factor of the polynomial. As a solution, k is a solution where the polynomial equals 0. And if it's an intercept, that means it's where it intercepts the graph. So all 4 of those things mean, like, the answers. Does that make sense?
Yeah.
We can use them mostly interchangeably, but there are subtle differences between what they technically are saying about the graph, and this is what that explains all that. Good. Turning the page.
Ah, yeah. What you do? I like this.
So, do you remember when we were doing quadratic equations? And it was always a parabola.
Yes.
Yeah.
Jake, what shape is a quadratic equation?
Quadratic equation?
Yeah.
Like on the graph.
Everybody who is listening would just be able to repeat what I said as the answer.
She's touching my feet.
I'm not. What shape is a quadratic?
Like when it's on the graph. Like when you graph it, it's like that.
What's that thing called? Because
Parabola.
Yeah!
Oh.
Well done, Jake. You made it.
You
Okay.
made
It's the
it.
shape of like
Okay. So when there's a parabola, what is the most interesting point on the parabola?
No,
What is it called?
The vertex.
low-
The vertex.
Full-
Absolutely, because that's the turning point for the graph, right? So, let's think about this. What degree is a quadratic?
4.
No.
3.
Are you just guessing?
2.
What does degree mean?
How many answers or solutions it will have?
We can
Oh,
go
no,
further.
How many times
and-
it will turn?
The
No.
highest power.
The
in
highest
the
power of the
function.
polynomial. Yes.
Oh,
Yeah.
so if it's a quadratic, then it starts off at x to the third, because
No.
then there's the extra number.
No.
No, when it,
X to the third is a cubic.
oh,
No, it's a quartic. What's
Wait, what do you-
quadratic?
For some reason, I think
We did a
quadratic is
whole
X-
entire chapter
oh,
on just
x
quadratics.
squared.
X
Oh, that
squared.
annoying little thing. Yeah.
Yes. So
I
the
was thinking
degree
it was
is
X before.
2. How many times does the graph turn? If,
2 to
if the degree is 2, how many turning points are there?
1.
One.
Yes. What's a cubic look like? A cubic function. Just draw it with your fingers.
1.
Yeah, it looks like that, right? How many turning points does that have? How many
2.
times does it change direction?
2.
A quartic looks like a W, okay? How many times does a W-shaped graph change
3
direction?
times.
3. Do you notice a pattern?
Mm-hmm. It's 1 less.
In the degree.
Yes. So when we're talking about quartics and cubics and quadratics, like just right now, we're talking about just x squared, x to the third, x to the fourth. We're not talking about 3x squared plus 15x minus blah, blah, blah. Those other numbers can still affect the way the graph looks, but they can't affect the general shape. Does that make sense?
Mhm.
So a graph has at most its degree minus 1 turning points. It's possible that it has less than that, but the highest amount, n minus 1, where n is the degree.
Okay.
Then, the only other thing we need to discuss are local maximums and local minimums. What's a maximum?
The highest. The most it could be.
Yeah. If we're talking about local, that means we're not talking about the graph entirely. Like if I were talking about teenagers, and I just said like, teenagers love,
Pizza.
I want to pick something less likely.
Broccoli.
New England clam
Exercise.
chowder.
Ew.
Ew.
But who knows? That could be right? I'm generalizing. I'm just
Okay.
talking about teenagers. So if 51% of teenagers like New England clam chowder, then I can say teenagers like New England clam chowder. If even 1%, I can still say teenagers like it
Mhm.
because teenagers do. Right?
Mhm.
Right. But if I'm talking about locally teenagers like New England clam chowder, now you can talk about like a specific region. And you can say, nah, probably not. We'd probably much rather have tacos or sushi. Right?
Mhm.
Yeah? Does this make sense?
Yeah.
So there's a difference between talking about the entire thing, the entire population, and locally, just one little region. So talking about a graph, local means we're only talking about a region. So if we're looking at a cubic, right? Cubic that does this, and we ask for a maximum, there isn't one because it goes up forever.
Mhm.
But if we talk about a local maximum, that's going to be its turning point where it goes from going up to go down. So that's just one part of the graph.
There's one, like...
Yes. So, looking at example 2, is there a local maximum to A?
No. Because it's just one thing, and then it keeps...
Isn't it 2?
It's not... There's not a pattern, so you can't pinpoint.
It's at y equals 2. There is a local maximum right there. Because we can see that there is, if we focus in on just one part of the graph, there is a highest point. If we look at the whole graph,
Wait, so
there's
that-
not
The what? The maximum?
local maximum.
Oh, okay.
It's the local maximum in between -1 and 1.
Mhm.
Does that make sense?
Mhm.
Okay. Is there a local minimum?
Mhm.
What is it?
Y2? -2. Y -2.
Yeah, or x equals +2, y equals -2. That's the local minimum. Now, is there...
it just going to be the negative of it for the minimum every time? Or is it going to be different? Okay.
You would have to look at it and see what it is. These, you will not be able to figure out using math without graphing until calculus.
Okay.
Calculus, if you want to find the answer, is going to take you like 5 seconds. So you haven't learned that math yet. So, anyways.
Okay.
I wish you would learn that math. It's amazing. I love calculus. It's so much fun. Okay. So, is there an absolute maximum to the graph in example 2a?
No.
No. These are the two options. Local or absolute. Okay? Does this
So
all
it's
make
called
sense?
absolute.
It's
so they're
absolute.
asking you
Right.
to-
If it's like a parabola,
Okay.
that will have an absolute maximum or minimum because it only has one turning point. So it will for sure either have a highest or a lowest point on the whole graph.
But not both.
Right, not both ever. Okay.
Is that it?
That's it. That's exactly.
Here's my 6.2, 6, 6, and 7, and then my quiz.
Thank you. Okay.
Well,
You
and
know?
then I'll have by next
Quite
Wednesday.
a
I'll
bit.
try to have all the ones I missed.
Okay.
Put that in my folder. It's a lot of math I have to redo.
But you get to redo it. Yay!
Yeah.